Why we need storm spotting. This is the condensed version of this training. I will tell you too that while we go through this fast, there's a lot of extra material online. We have a YouTube channel that's got all kinds of videos on there, basic spotting, advanced spotting, radar interpretation, severe weather meteorology. There's so much online that you can do now. So if we go too fast, if you miss something, you can go online and review it in much more detail. So this will be an overview, and hopefully if you're new to this will whet your appetite to go look for other stuff. The reason that we're here tonight is to give you the very basic information that you need as a storm spotter to be able to make reports, to assist the local officials. That could be emergency management in your city or county. It also helps us to know what's going on. And also, your reports provide what we call ground truth to help us know what's really happening in the local area. Storm spotting and storm spotter training is not to teach you to be a storm chaser, to be a meteorologist, a forecaster, a photographer. This is a brief overview to kind of give you the basics about safety and the basics about what to look for to make reports. There's places online where you can probably learn about all this in more detail, but again, we're not going to get into all that this evening. The job of a spotter is to safely observe, identify, and report. You are an observer. You're not a hunter. You're not looking for tornadoes. You're not looking for severe weather. You're not trying to find things out there. You're observing what's going on and reporting what you're seeing. That's what a storm spotter does, and that's one of the things that set a storm spotter apart from a chaser. Chasers, one of the differences is they go out looking for a tornado, or I'm going to go find this severe weather and I'm going to drive to where it is and I'm going to see it and photograph it or whatever. There's a lot of overlap between spotters and chasers, but anyway, spotters, really these are your three main jobs, and we're going to give you really quick information to help you be able to do that safely. Why do we still need people? Why do we still need storm spotters? With all the technology that we have and all the radars that we have, can we not just use the radar to issue the warnings or to tell us what's going on? Well, no, we can't. And I work in a building where the top researchers who are developing the next generation of radar that you won't even see publicly available for a decade or more. And I can tell you there's nothing they're developing that's going to put spotters out of a job. You have job security as a storm spotter. That big fat storm spotter paycheck that you get is not going away. So you're in good shape. So I know Rob pays really well, people that are storm spotters. See Rob after class for that. No. Why do we need spotters? Well, radar, and this applies to every radar. I don't care what app you have, what website you're on, what TV station you're watching. Every single radar has this limitation. The further away you are from the radar, the higher up we're looking. Period. So if we have a radar on the south side of Oklahoma City looking at a storm over Stillwater, we cannot see what's going on at the lower levels of that storm with that radar. We need spotters to tell us what's going on. Channel 5's radar cannot see it. Channel 4's radar, Channel 9, radars in Tulsa, Wichita, none of them can see what's going on at the bottom part of that storm. You are the only person or the only thing or the only sensor that we have to tell us what's going on in that storm. Any distance from the radar is looking in the middle and upper parts of a thunderstorm. Where the rubber meets the road and the important stuff is happening is down there. So that's where the hail's falling. That's where the wind's blowing. That's where the tornadoes are forming. The wall clouds are turning. That's where the important stuff is happening. And that's where spotters are needed, have always been needed. And through the rest of my career, there won't be a time when we don't need storm spotters. They are a vital part of our information and the only way that we know what's going on in the local communities. Staying safe, we talked about tornado safety earlier. This is very specific information safety for storm spotters. I'm going to kind of use this diagram as we go through the training to kind of show you the danger zones around a storm. As we talk about hail and tornadoes and straight line winds and lightning, the different threats have different danger zones around a storm. And this is a supercell. This is the kind of storm we're going to talk about for the rest of the evening. It's not the only kind of storm we deal with, but it is the most important kind, and it is what we're going to focus on. So as we go through the next few slides, I'll show you a danger zone map of the different hazards. The main threat that we have to worry about as spotters is lightning. Every thunderstorm, by definition, has lightning. It produces lightning. If you hear thunder, that means it's lightning somewhere. If you can hear thunder or see lightning, you're close enough to be struck. Lightning can strike 10 or even more than 10 miles away from the rainy part of a thunderstorm. And most people that get struck by lightning are not out in the rain and the hail. They're out there trying to finish mowing the yard before the storm gets to them, or they're running out to try to wrap up that t-ball game. They're in the last inning. The rain stops. You run out there and try to finish. People get struck by lightning before the rain starts, after the rain ends. So no place outside is safe when there's lightning in the area. You need to be in an enclosed vehicle, or you need to be inside. It doesn't count to be under a tree, under an awning, in a tent, under a picnic shelter, in a convertible, on a motorcycle, in the back of a horse, a tractor. These are places where people have been struck by lightning over the past recent years. Every year, somebody is struck and killed by lightning on a beach, on a boat, on a golf course, or under a tree. Every single year that happens, even though we say over and over and over again, those are not safe places to be. The danger zone for lightning, that yellow box, everywhere. Anywhere around a thunderstorm, you can have lightning. Sometimes the most intense lightning is going to be in a certain part of the storm, maybe that core of the storm where all that purple and red is, but you're just as likely to get struck by lightning out here, out away from the core of the storm, or back here after the storm's gone. Again, lightning can jump out away from that rainy area. So don't think that you have to be in the rain and the hail and you have to be in a severe thunderstorm warning, for example, to get struck by lightning. We don't issue lightning warnings. You get a natural lightning warning. Nature provides you with a lightning warning in the form of thunder and lightning. If you see or hear either one of those, that's your lightning warning. Consider yourself warned. What happens after that is up to you. Flooding. Most people that die in thunderstorms in an average year are flood-related fatalities. Most of these happen when people are in vehicles. They either drive into areas where water covers the road. We see a lot of examples where people think the barricades apply to everybody but them, and they'll drive around the barricades or through the barricades. I've got to get where I'm going, and I'm driving through there no matter what. The motto, the slogan that we have is when the roads are flooded, turn around, don't drown. If you don't know how deep that water is, don't drive into it. What's sad about these situations is this guy right here, this is May 31st in downtown Oklahoma City. If he's got a cell phone, what do you think he's doing right now, or has already done? He's probably calling 911. So his life is in danger. His vehicle is going to be in bad shape. And then now other people, firemen or police or somebody's got to go out there and pluck him out of the water and put their lives in danger. So just if you don't know how deep the water is, stay out of the water. Large hail. We've experienced this around here, and it happens just about every year. Even if we have a slow tornado year, we're going to have large hail. Hail, when it gets to be about golf ball size or bigger, that's when we start to see a lot of damage occurring. But you can get problems with hail. This is not from last week when we had snow and sleet. This is 6 to 8 inches of pea-sized hail that fell very, very quickly from a non-severe thunderstorm. We wouldn't issue a warning for this because it's not as big as a quarter. But that is driving on ice. The hail is ice, so that's just like driving last week on some of the snow and sleet-covered roads. Also, what happens when we have a lot of hail that falls like that is we get something called hail fog, and the reason we can't see down the road any further there is all that cold air associated with the hail that's on the ground. When it was just 80 degrees outside, it forms fog very quickly. So you can get in trouble on slippery roads and zero visibility in fog, even in hail, even if it never gets to be severe size. Large hail is most common in this part of the supercell on the back of the storm. We're going to talk about that area back where that hook echo is. This is where the most intense updrafts are in this thunderstorm. And updrafts are the fuel supply for this supercell. The stronger the updrafts are, the bigger the hail potential is. So in supercells, it's not uncommon to get golf ball size hail, and we can see even hail that's 3 to 4 inches in diameter, DVD size hail and things like that with these very, very intense updrafts. Straight line winds happen with every single thunderstorm. Every thunderstorm has an updraft and a downdraft, and the downdraft is when the cold, rainy air comes down out of the storm and hits the ground. Sometimes that can be very intense, and sometimes we can get an intense gust of straight line winds, very concentrated, and we call that a downburst or a microburst. This is an example of a microburst that hit Norman A couple of years ago had winds over 90 miles an hour, caused lots of damage. FEMA came to town. People were displaced out of their homes. Wasn't a tornado, but 90-mile-an-hour winds will do the same damage, whether you call it a tornado or straight-line winds. And again, this can happen much, much more frequently than a tornado would. And that causes damage. And what we find a lot of times, especially for people that have never been through any training of any kind, is people automatically associate pictures like this with a tornado. They think, that tree's been there for 50 years. As long as I've been alive, that tree's been there. It had to be a tornado. Or the barn was destroyed, and I heard a loud roaring sound, and it sounded like a freight train or a waterfall or a jet engine. That means it was a tornado. Or the tree fell down crooked. It didn't fall straight over. It kind of blew down and twisted as it fell. That means it was a tornado. None of that means it was a tornado. If you get 90 or 100-mile-an-hour winds, it's going to make a loud roaring sound like a freight train, waterfall, all the tornado-like sounds that you hear. Anyway, as a spotter, what we want you to do is not try to speculate or guess what might have caused the damage. If you didn't see the damage happen, we still need to know about the damage, but tell us you've got damage. Tell us you've got a barn destroyed, a large tree blown over, power poles down. Then we'll try to make the determination of what it was. Sometimes people will start guessing that, well, it must have been a tornado that did that, and then that kind of spreads, especially now with social media and things like that. Then all of a sudden we have a newspaper calling us or a TV station or radio station saying, yeah, I heard there was a tornado in Stillwater last night. Where did that come from? So anyway, report the damage, report what you see, but then we'll try our best to make a determination of what caused the damage. Around a supercell, severe winds, these damaging downburst winds or straight-line winds can occur in a couple of different areas. One area is on the front of the storm, and I didn't mention this earlier, but this is our model supercell for the evening. In this case, and in most of the slides we're going to see, let's assume that this supercell is moving from the southwest to the northeast. So we're going to call this the front of the storm. The storm's moving in this direction. So if you're sitting up at this intersection right there, you're looking at the front of the storm right here. As it approaches you, this is the back of the storm, the rear of the storm here. So this is the front, the back. So you can there's an area where we may have severe downburst winds or microburst winds on the leading edge of the storm, the front of the storm. There's also an area that we won't really get into in detail tonight called the rear flank downdraft. That's an area on the back of the storm where you can have some intense winds too. I know one of the most nerve-wracking times for me in our office recently was a couple of years ago when we had a supercell with a tornado warning that passed north of the office, and the rear flank downdraft, those winds that swung around the back of the hook that hit the office, all the trees laid down. It didn't last very long, but that's some of the strongest wind I've ever seen, and it wasn't a tornado. It wasn't even in the rainy part of the storm. It was back here in the clear air as the storm passed, north of us. Tornadoes, obviously, get most of the attention. Tornadoes are the most violent storms we have to deal with. Fortunately for us, even here in Oklahoma, tornadoes are rare. Most spotters will never see tornadoes. There's people that spend thousands of dollars and put thousands of miles on their vehicles every year that never see tornadoes, that try to see them. There's people that work in my office that have lived here for nearly 60 years, their entire lives, who want to see a tornado, who've never seen one. So I don't want people who are new to the area or new to spotting to think about, well, it's going to be like shooting fish in a barrel. It's Oklahoma. There's going to be tornadoes half the days in spring. I'm going to go see them. But that's not how it works. Probably you'll never see one. But we hope you don't. But if you do, you need to know how to deal with it and how to report it. The number one tornado danger is the flying and falling debris. We already kind of talked about that earlier in the safety section. The danger area, the danger zone for tornadoes in this supercell is on the back of the storm. I'm not saying it's 100% that you'll never see a weak little spin up of a tornado somewhere out in here or down in here somewhere, but the tornadoes that we're worried about, the ones that are going to be longer lived and damaging, are going to be back on the back side of the storm. In this case, our supercell is moving southwest to northeast. It'll be back here on the southwest edge of the storm. And we'll get into that a lot more in a second. Radar data is freely available now, and you can get apps on your phone. You can get it on your computer, your iPad. It's on television. It's on the internet. The radar data that I can get now on my phone is so much better than the radar data that when I first started in the Weather Service, we had to issue warnings with. It's amazing how fast this has come along. And the technology is awesome, and it's easy to get radar data. But I urge you, first of all, I urge you to use radar data as a spotter. If you don't use it, it's kind of silly, honestly. I mean, we obviously want you to look at the clouds and tell us what you're seeing and not be looking down at your phone the whole time. And we don't want you reporting to us what you see on radar. That's unnecessary because we have more radar than we can even look at sometimes. But we need you to take radar data seriously. I put don't bet your life on radar data. Just because you can put highly detailed map backgrounds behind this radar data, like this is the May 19th tornado, Luther, Wellston, moving up toward Kearney. That's the debris ball for the tornado there, and the radar says that little green triangle is where it thinks the tornado is. And the map backgrounds here, you may not be able to see it, but it's got driveways and little tiny roads and gravel roads on here. And you may think that just because you've got detailed map backgrounds and that little green triangle is right there, that you can maneuver around this storm and that the radar data is extremely precise, and that is exactly the spot on Earth where the tornado is touching. Radar data is inaccurate. Aside from the fact that you're probably looking at data that's old, that's already happened several minutes ago, the locations that where you think the tornado might be based on radar can be several miles off. Especially up here, where we're some distance away from the closest radar. We've done studies and we found sometimes where the difference between where the radar thought the tornado was and where the tornado damage actually happened can be as much as 5 to 10 miles. So if you're betting your life on this and thinking, well, the tornado's right there, I can take this little gravel road, work up here, jog around to the right, and then go north. And I mean, the tornado may be out here, it may be down here, it may be back in there. Don't think that that's right where it is. So it doesn't matter how accurate or how precise or detailed your map background is. The radar data that you're looking at has limitations. And again, it doesn't matter how much your app costs, what station you're watching. It all has the same limitations. Another one of the big limitations is what you're looking at is historical information. You're looking at information that's already happened when you're looking at radar data. The only way that you can see anything close to live radar data is watching one of the Oklahoma City TV stations who's showing their own radar. And when they're showing their own radar, it is as close to live as you're going to get. Because their radar doesn't do what ours does. Their radar scans around at the same elevation the whole time. So the antenna's going around and it doesn't move. It doesn't go up to look at what's going on the upper parts of the storm. It just goes around. Our radar has to go around at the lowest level and then go up and go around again and go up around again. It takes 3, 4, 5 minutes for it to do that. So you are almost guaranteed, if you're looking at Radar Scope or OK First or our website or just about any place that you can get radar data online or on your mobile device, it's old. And if you've got a storm moving 60 miles an hour and you're looking at data that's 5 to 10 minutes old, the storm may be in another county by the time you see it on radar. So again, I love radar data. I would not be a spotter without using it either directly or indirectly, having somebody help me, hey, I'm looking at radar and that storm's moving northeast, that kind of thing. But you have to know the limitations, and you can't. We've had people that have nearly been killed because of not using radar data properly. They didn't notice that the radar image hadn't updated in 15 minutes. So where they thought the storm was, they thought the storm was 30 miles to their southwest, and it was right on top of them. So remember, safety first. We do not want your report. I don't care if we never get another spotter report of hail, wind, tornado, if we never get another picture of a storm, that's fine with me. If it means somebody has to do something stupid or dangerous or put their lives in jeopardy or put their car insurance premiums in jeopardy by driving too close to a storm, I don't want the information. You can keep it. We don't want it. That's not what this is about. It's not about a contest to get close to the storm or to get the best pictures of a storm. It is to tell us what you're seeing and to be safe doing it. All right, identifying key features. We're going to get into the supercell, talk about the storm. A supercell is the most important kind of storm we deal with. We got all kinds of storms that happen, but a supercell is the one that produces the most significant severe weather. So the biggest tornadoes, the biggest hail happen with a supercell storm. And what makes a supercell storm different from other storms is it has what we call a rotating updraft. Every thunderstorm has an updraft and a downdraft, but the supercell storm forms when we have certain ingredients in the atmosphere that come together. These are the 4 ingredients that we need for a supercell. And this is stuff that we get into in our advanced training. We have an advanced training coming up online April the 7th, I think it is. And we'll get into this in more detail. But this is when we're doing a forecast, or you read an outlook or a discussion that says, the CAPE values are 3,000 and the dew points are 70 and there's a dry line coming and the 0 to 1 kilometer shear is this. All of those are pieces of a puzzle that we need to put a supercell together. They're ingredients. And just like, making a cake, if you don't get the ingredients just right when you're making a cake, it's not going to turn out right. It's either going to taste bad, or it's not going to look right, or it's going to not rise, or it's not going to something. You have to get the mixture right, you have to get the amount right, and you have to mix it together in a certain way and prepare it in a certain way. And the same thing with a supercell. We can have all these ingredients there, but the balance is wrong. We don't have quite enough moisture, we've got too much lift, not enough instability, too much wind shear. Any of these things that are slightly out of balance, and we're not going to get a storm, or we're not going to get a supercell. And it's even more complicated to get all this stuff to work together just right to get a tornado to form. So when we're trying to forecast tornadoes, we first have to forecast thunderstorms, then we have to forecast that there's going to be supercells, then we have to forecast that the ingredients are going to be there around a supercell to produce a tornado. So we have a lot of supercells here, but we don't have as many tornadoes as we have supercells, thankfully. So anyway, we'll get more into this in the advanced training, and there's other sources I'll tell you about in a minute where you can get more into this in detail. But this is what we're forecasting when we're forecasting severe weather. And these are the pieces of the puzzle that come together to make a supercell. Every thunderstorm that we have here in Oklahoma has an updraft and a downdraft. The updraft is the fuel supply for the storm. That's the warm air that rises up, that forms the clouds, that eventually forms the rain. That's air rising up into the atmosphere. What goes up must come down, so every thunderstorm also has a downdraft. When the rain starts to form in a storm, it cools the air around it. That cool air is heavier, so it sinks down to the ground. So we've all been outside before when there's a thunderstorm coming and you feel that gush of cool air that comes out. That's from the downdraft. Every thunderstorm has that. That's not what makes it a supercell. What makes it a supercell is that rotating updraft. And that's what makes the storm be more organized and helps it hold itself together longer, and also helps it be more efficient in producing severe weather. Now notice that red arrow in this updraft, notice that it's not pointing straight up in the air. Notice how it's kind of leaning over to the right a little bit. That's because of the wind shear. The wind shear in this case, there's, on a tornado day here in this area, we might have winds at the surface, at the ground where we're standing here, maybe blowing from the south at 20 miles an hour. Up at the top of this storm, tens of thousands of feet up, the winds may be blowing 100 miles an hour from the west. That's wind shear. So that's causing the storm to lean over. It's pushing the top of the storm over to the right. And what that does is it causes the updraft to go up here, the precipitation forms, and it falls over there. If you can keep that updraft and downdraft separated, close together, but not too close together, that's when you get that balance. That's when you can get this supercell that becomes a severe weather machine and can go on for hours. We've had supercells that have developed in southwest Kansas and moved all the way down to Louisiana. We've had supercells that have developed in southwest Oklahoma and moved all the way to Illinois. One storm or one system of storms that just goes on and on and on. You get the right mixture and the right balance, these things can just become machines and just keep going and going and going. So that's what happens, but it has to be just the right balance. So that's why that's leaning over like that. That's because of that wind shear. So when we tell you that Doppler radar indicated a developing tornado over Payne County, we can't see a tornado over Payne County with the radar. None of the radars can because we're not looking at the bottom of the storm. What we're seeing is this rotation in the middle parts of the storm. You heard the term mesocyclone or rotating updraft. Those are all kind of the same thing. That is the rotation in the storm that could produce a tornado. So we're taking steps. We've built a thunderstorm, now we're going to build a supercell, now we're going to start looking at what it takes in a supercell to get a tornado to happen. And to know where to focus our attention in a supercell, we have to know where the action area is. And the action area is the most likely place where a tornado is going to develop in a supercell. It's also the most likely place where there'll be the big damaging hail. The biggest hail is going to be there. When there's a storm out there coming toward us, or a storm out there that we're looking at, it can be overwhelming. There's this huge storm, the sky's dark, there's clouds here, there's clouds there, there's low clouds here, there's this there. How do you know where to look? Well, being able to identify where the updraft and downdraft is in one of these supercells is the key, because the action area is where the updraft and the downdraft come together. So in between the updraft and the downdraft area, that's where we're going to focus our attention. Now, every storm is not going to be easy to see that. Sometimes it's going to be very easy to pick out the features and you'll say, okay, that's exactly where I need to be looking. Sometimes it's going to be difficult, but again, each situation is going to be different. So how do you view the action area? Let's say that you're a spotter and you're in a vehicle, and your job is you're either sitting at a designated intersection, that's your spot to watch for storms at, or your instructions are to get to a spot where you can watch the action area or watch the area where there might be rotation or a tornado happening. Before you can ever do that, before you can ever be safe out there around a storm, you have to know which way the storm is moving. And you have to know which way the storm is moving constantly. Storms never move in a straight line. Storms never move at a constant speed. These are blobs of air and water. It's not like a block of wood. This is a process. It's air and water constantly changing. So storms wobble, they turn to the left, they turn to the right, they redevelop. One dissipates, a new one forms. There's all kinds of stuff. So, there's a storm coming across I-35 toward Payne County. You watch the weather at 6 o'clock, and Mike Morgan or whoever gets on and says, here's the supercell, it's crossing I-35, it's moving east at 20 miles an hour. You jump in the car and drive out there to see it. By the time you've gotten a mile down the road in your car, the storm has already changed direction and or speed. So you'll never know all the information you need unless you have almost a constant flow of radar information. That does not mean driving down the road with your iPhone looking at the radar while you're trying to spot. That means having a partner or having somebody on a radio or somebody guiding you or helping you. Safety is the number one thing. So where do you go to look at the action area? Well, once you know which way the storm is moving, generally speaking, and this is very general, if you've got a storm moving like in this direction, southwest to northeast or something like that, usually to the south of the storm, to the south of that updraft area is going to be the best viewing angle to see the action area. If we're sitting down here where that red X is, we can look up in this area. This is the action area on the back of the storm, kind of where that hook is that you see on radar. You need to be far enough away where you're not going to get hit by hail. You need to be far enough away where if the storm decides to turn, which they often do, that you're not caught unaware and trapped. You need to consider the road network, all kinds of things. We don't encourage anybody to go out and do this. We don't encourage people to go out and chase storms or get near storms in your vehicle unless you're experienced, unless you have a network supporting you, people, radar, partners, things like that. Because the storm may turn. These supercells are known for turning or splitting. Sometimes a storm will split into two pieces. One will race off to the north, one will dive down to the southeast. And if you're not paying attention and don't have access to radar data to help you know that, it's very hard visually sitting out there on the side of the road to know that a storm has gone from moving toward the northeast to now moving toward the east, especially if it's moving slow. It's just hard to see that. So you have to be very careful and know, like I said, which way that storm is moving. So identifying the action area means identifying where the updraft and downdraft are. Visually, what we're looking for with an updraft is something called a rain-free base. It's also called an updraft base, so if you get online and see references to that, those are the same thing. That's just the smooth, flat cloud base on the backside of the storm. That's where all the air is rising up into the storm, so that's why it doesn't look like there's a lot of rain or anything falling down out of the storm, because that's where all the air is going straight up. Here's another example. This road goes straight north, so on the west side of the highway, this is all updraft over here. Smooth, flat cloud base on the back of the storm. Our downdraft would be over here. We'll talk about that in a second. Now, just because you see a smooth, flat cloud base doesn't make it a supercell. Every thunderstorm is going to have that. Every thunderstorm has an updraft. What we're looking for is a supercell that's got that updraft and the downdraft. The area that we're going to be zooming in on is the action area that's right where those two things come together. Every storm has a downdraft. That's the air coming down out of the storm, hitting the ground, and then moving out. It's just like if you get a bucket of water. If I poured a bucket of water on the ground, it can't go directly into the ground, so it's going to hit the ground and then spread out. And that's what we see here in this example. Here is our supercell off in the distance. This is our updraft area, air rising up into the storm. Our downdraft area is over here. Where those two things meet, or in between those two things, is our action area. And that's what we're going to start focusing on next, is that feature right there that's called a wall cloud, and that's the next step toward a tornado. So we've got a storm, we've got a supercell. Now we're going to start to look for the next stages before we get to a tornado, and that's a wall cloud, then a funnel cloud, and then we get to the tornado. These are going to be the most rare things you ever deal with as a spotter. Now, there'll be wall clouds this spring. There'll be supercells this spring. There'll be a lot fewer funnel clouds than we have wall clouds. And there'll be a lot fewer tornadoes than either one of those. Most wall clouds never produce a tornado. Most funnel clouds never become a tornado. But we need to know how to identify all of those. Remember, the action area is back there on the back side of the storm where the updraft and downdraft come together. The wall cloud is going to form, in most cases, right there. And the wall cloud is a distinct lowering of the cloud base. To be a wall cloud, it has to be connected to the bottom of the storm. It's not a standalone cloud. It's not just floating out there by itself. It has to be connected to the storm. Here's a wall cloud that happened down near Wichita Falls last spring. I think it was in March or April. And this is an example of a wall cloud. We're looking straight north this road, so this wall cloud is kind of almost due north of us. It's an isolated lowering of the cloud base here. It's right in the middle of where this updraft area here is. How can we tell it's an updraft? Well, it's kind of hard to see the cloud base there, but we've got very bright skies back there, so that's a sign that we're seeing upward moving air right there. This is our downdraft area over there. And the wall cloud forms right where that updraft and the downdraft kind of come together there on the back of the storm. The wall cloud forms there because of a very special set of ingredients that come together. And I'm not going to spend a lot of time on this, but the wall cloud forms where it does for this very specific reason. The wall cloud is not going to form in any other part of the storm. So if we tell you there's a supercell along I-35 and it's moving into western Payne County, you go look out the window to see it, and you see a low dark cloud moving toward, on the horizon, moving this way. That's not the wall cloud. The wall cloud's not going to be visible in the front of the storm. The wall cloud is on the back of the storm, and the reason it's there is because you've got the perfect mix of updraft and downdraft, air moving up, moisture, all that stuff working together. That's why the wall cloud forms where it does. It doesn't form anywhere else. It doesn't form on the front of the storm. We'll talk about what that cloud is on the front of the storm in a minute, but wall clouds happen where they do for a very specific reason. So if you see a feature that you think may be a wall cloud, a couple of things to look for. Remember that it has to be connected to the cloud base. It is part of the thunderstorm that's lower down than the rest of it, and it has to be in the right part of the storm. If the wall cloud is not on the back side of a supercell, where the updraft and the downdraft come together, then it's probably not a wall cloud. It's probably a shelf cloud or some other feature. This is an example of a wall cloud and another feature called a tail cloud. We'll go back and I think this will loop through again, but this feature that we see at the very beginning of the video here is a tail cloud. And the tail cloud is more of a horizontal cloud. It's not a tornado. This is it here. This is actually moisture feeding out of the downdraft area into the wall cloud area here. So that sometimes you'll see that feature there. And here's a couple of other examples of what that tail cloud might look like. Again, a tail cloud's not a tornado, but it is a sign that that wall cloud is gathering moisture or gathering humid air up into it. Next danger sign is rotation. If we have a wall cloud, then we start to look for a rotating wall cloud. Rotation is organized, sustained cloud motion around a vertical axis. So this is one of the most important things for a spotter to know is what rotation is. Rotation is not just clouds moving. Some people see clouds moving around a thunderstorm, and any cloud motion is rotation. Rotation is like the horses on a merry-go-round going around. It's clouds moving in a complete circle, and it's around a vertical axis. So if you see what you think is a wall cloud or a funnel cloud out there, if you hold a pin up or take something and hold it up, what you're looking for is clouds moving in a complete circle around that axis. It's not clouds blowing in one direction only. It's clouds going in a complete circle. And that rotation is one of the key danger signs we look for. Now, if you've got a wall cloud, is it going to produce a tornado? Probably not. If you've got a rotating wall cloud, is it going to produce a tornado? Still probably not, but the chances are higher if it's rotating. So every step that we're going toward a tornado is more important for you to watch what's happening. And as we're watching what's happening, spotters need to look at the trends. It's not just telling us, it's not just looking out the window and going, oh, there's a wall cloud, and then, going back to watching Dancing with the Stars or whatever. You've got to watch it. You've got to pay attention to it. You have to have patience and persistence and watch how the thing develops, because the danger signs develop over time. And the danger signs can develop very slowly. Sometimes they can develop very quickly. We've gone from having no storm to having a tornado in less than an hour in some extreme cases. So knowing how these features are developing is important. Are the winds getting stronger, blowing toward the wall cloud? Is it getting lower to the ground? Is the rotation increasing? All of those are very, very important danger signs that we could be getting closer to producing a tornado. Here's an example of rotation. This is our rotating wall cloud here we're zoomed in on. If we imagine a vertical axis sticking in the middle of that area that we suspect of rotation, everything is going in a circle. The clouds closest to us on the front of it are moving left to right. Clouds on the back side are moving right to left. So there's circular motion going on there in that wall cloud. Another key thing to keep in mind with wall clouds and supercells is they will go through cycles where the supercell develops a wall cloud, the wall cloud rotates. For some reason, the ingredients get out of balance and that wall cloud dies. 10 minutes later, further to the northeast, a new wall cloud develops. So these can go through cycles. So never ever turn your back on a supercell if it's produced a wall cloud, especially a rotating wall cloud, because even if it looks like it falls apart, it could be redeveloping in another location. So you always have to watch it. Now, eventually it's going to die, but sometimes they go through cycles for an extended period. The next step is a funnel cloud. A funnel cloud is defined as a violently rotating column of air, not in contact with the ground. What we're looking for with a funnel cloud is rotation. If you can see the cloud feature rotating, it's not enough for it to be just a cloud shaped like a funnel. It has to be rotating. So we're watching for signs of rotation. We're watching for persistence, for organization. And again, trends are very important for storm spotters. So how is it changing over time? Is the funnel cloud getting lower to the ground? Is it rotating faster? Those are the key things that we're looking for. Tornadoes are the final step in this process. Hopefully we never get to this point, but if you see that, that's pretty obvious what that is. That doesn't take a lot of training to identify that as a tornado, but it's not always that easy. Some of the times, oftentimes the job of a spotter, this is one of the most difficult things to do, is to tell if something is actually a tornado or not. The definition of a tornado, it's a violently rotating column of air in contact with the ground and in contact with a thunderstorm cloud. So to correctly identify something as a tornado, you have to be able to tell if it's in contact with the ground and the cloud. And that's not always easy to do. Remember, the danger zone in a supercell for a tornado is there on the back side of the storm. So, is it possible to identify if this is a tornado or not? Well, remember the definition. Is it violently rotating? Well, this isn't a video, but I'll tell you it is violently rotating. Is it extending from a thunderstorm cloud? Yeah, that's a thunderstorm. We're so close that it's hard to tell if that's a wall cloud or not, but it is a violently rotating funnel at this point. Okay, the third thing we need to know, is it in contact with the ground? Is there any way to tell if that's in contact with the ground? Not in this case, there's not, because we have these pesky trees in the way. As a spotter, you should always report only what you see. We do not abide or go by any, I've heard this halfway down rule, or if the tornado, or if the funnel is 3/4 of the way down, that means it's a tornado. If you can't tell if the funnel's in contact with the ground, then call it a funnel. Be descriptive in your report. I've got a violently rotating funnel. There's trees in the way. I don't know if it's in contact with the ground or not. There may be another spotter who's further up the road who can see behind those trees, who can tell. But just report what you see. Now, if we could wave a magic wand and get rid of the trees, now what would you call it? Well, now we have a violently rotating funnel up here, and it looks like we do have some contact with the ground. Does it matter that there's not a dark funnel that connects those two things together? Doesn't really matter. The tornado is air, so it matters that there's a circulation there. So if you can determine that this rotating dust on the ground is caused by that, then I would call that a tornado. Again, sometimes it's not going to be easy. Sometimes you're not going to be able to see what's going on at ground level, but you should never speculate. You should never guess. You should always just say what you see. Here's the life cycle of a tornado, and this goes pretty quick. We go from a rapidly rotating wall cloud right over the highway here just ahead of us. We see a funnel developing very, very quickly right over the highway. And, as we're reporting this is exactly what I'd be reporting. There's a funnel. Looks like the funnel's extending closer down to the ground. I can't tell for sure if it's in contact yet. At some point right in here, this becomes a tornado. And exactly when, it's hard to say. I wouldn't call it a tornado now because I don't see any clear evidence that it's in contact with the ground. Start to see a little swirly stuff going on near the ground here underneath that funnel. And here in just a second, it becomes pretty obvious. That's what we're dealing with. Every once in a while, you'll see a little wisp of something there underneath it. It's getting pretty close to the ground level there now, and now it's obviously a tornado. This developed very, very quickly, and sometimes this can happen under the right circumstances, and sometimes they develop sometimes they dissipate just as quickly. This one's not going to last very long. Be very careful also if you're reporting a tornado. Be very careful with the words that you use. We got a report not too long ago of somebody reporting a very large tornado. When I think of a very large tornado, I'm thinking of the width. I'm thinking of how wide it is. What this spotter was telling us was it was a large tornado. It was tall, and it was like an elephant trunk. So it was long, is what he was saying. It wasn't large as in wide. So be very careful with the words that you use to describe it. There's chasers jargon and slang out there, wedge and stovepipe and elephant trunk and all that. I don't really care so much for those terms, but just be very careful how you describe the tornado, how big it is. What does big mean? What does wide mean? Sometimes just those kinds of reports can cause issues by people overhearing them on a scanner or something like that. So just be factual. Just be as factual as you can. Describe exactly what it is you're seeing. It's also very, very important to remember that the tornado is not the cloud that you see, it's the wind. So in this example, this is an example from May 31st of 2013, the El Reno tornado that killed 8 people in vehicles, also killed at least 4, maybe 5 storm chasers died in this storm. One of the reasons they died is they misjudged the location of the tornado, because that's what the tornado looked like to them. If you're sitting over here on this road and you're looking off there to the west or the southwest, that tornado is huge. You're looking over there and it's close to being a mile wide, which you can see, the visible tornado. What got people in trouble was the tornado was twice as big as that, almost 3 times as big as that. So this tornado it's quite likely the tornado was 3 miles wide or more at its widest point. We're honestly still kind of trying to investigate some of that. But if you're sitting over here, this is what happened. But by the time people knew that the tornado was much bigger than it looked, by the time the tornado was overtaking them, it was too late to drive away. We had people that were, wind flowing into this tornado at 80 miles an hour. They're driving a little small car on these gravel roads trying to go against that wind. It was just a horrible, horrible, very sad, tragic situation. These were experienced, seasoned chasers that do this for a living and were doing this for decades. It would be very easy for me or any of us in this room to get caught in a similar situation. So there is absolutely no purpose, no need for getting that close to a storm as a spotter. So just keep a very safe distance. All right, we're going to speed up here because it's getting close to my bedtime and probably yours too. Scary looking clouds. These are going to happen every time we have thunderstorms. There were scary looking clouds in the sky yesterday as we had the rain going on. These are clouds that look like a funnel, that look like a tornado maybe, that look like a wall cloud, but are just innocent looking, generally what we call Scud clouds. As a spotter, how do you know that's not a tornado right there? Well, we'd have to watch it for a little bit. We'd have to see if it's organized, if it keeps that shape. Is it in the right part of the storm? Does it even make sense for there to be a tornado with this storm? Is it a supercell? Is it rotating? What we'd find in all those cases is we would watch these cloud features. They would fall apart after a period of time, or they're not rotating, they're not organized. They're just kind of hanging there. And that is not a sign of a tornado. It's much more difficult to determine that at night, but in all these cases, these are just scary looking clouds. Shelf clouds form on the leading edge of a thunderstorm, on the front of a storm. So when that supercell is coming across Interstate 35 into western Payne County, what you're going to see if you go out and look at off in the distance on the front of the storm is a shelf cloud. And it can look very, very scary and very ominous. That's not a wall cloud. That's not where a wall cloud is going to be. Another scary looking cloud is Mamadas Clouds. Mamadas Clouds form on the underside of the anvil of a thunderstorm. These are tens of thousands of feet up. They don't have anything to do with severe weather. They don't have anything to do with tornadoes. I hope you have your camera when they're out there because you can get some incredible pictures. Some of these pictures don't even look real that we get of Mamadas Clouds, but they can be very dramatic looking. They have nothing to do with severe weather. They're nothing you report, but they are things that sometimes people get nervous about when they see them. Storm spotting after dark is the biggest challenge that we face. The people out in far western Oklahoma in a typical year will get those dry line storms that form at 3 to 5 in the afternoon. Tornadoes happening during the day. By the time those storms get all the way over here east of I-35, it's dark a lot of the time. So we have to deal with things like this. Using lightning to help you is really your only crutch at spotting at night. Where the lightning flashes makes a difference. I mean, I think we're dealing with a tornado here, but every lightning flash looks like something different. The lightning flashes that flash back behind the storm, it looks like the tornado is further away, to me at least, that dark part that we're seeing. But when the lightning flashes between us and the tornado and you see the white funnel that's lit up, that looks like it's much closer. So it's very difficult. Your depth perception, your judging distances and locations is very, very difficult at night. As a spotter, remember, report what you see. So in this case, over in eastern Oklahoma a couple of years ago, we're looking at something here. There's a funnel. Fortunately, there's a lot of lightning, and there's a lot of lightning back behind this feature. So what do we call this at this point? Is this a tornado, a funnel cloud? What do you think? I think funnel would be a good guess right now. How are we going to know if it's a tornado or not? Well, we're going to need some evidence that it's in contact with the ground. It's hard to see that at night. There's some weird looking, almost looks like a dust or something there in the city lights. This is right over the city of Salisaw in eastern Oklahoma, but we don't know for sure. The power just went out for some reason, and now we're seeing kind of evidence of why the power went out. Those are power flashes that are happening at the base of that tornado. Now, power flashes can be caused by all kinds of things. Power flashes happen when the transformers explode, power lines go down, things like that. Has anybody ever been in an ice storm before? Power flashes. Damaging straight line winds can cause power flashes. A drunk driver hitting a pole can cause a power flash. So just because you see a power flash, don't assume that means a tornado. In this case, though, we're putting all the pieces of the puzzle together. Okay, I've got a funnel cloud. I can't tell for sure if it's in contact with the ground, but if you've got a funnel and you've got power flashes under it, that's a tornado. That's connecting the dots of everything that's going on. If all you see is the power flashes and you don't see this up here, then all you report is power flashes. You don't report a tornado. People get very excited when they see power flashes and start screaming tornado. That does not mean there's a tornado there. It does in this case because obviously we have some other evidence. We've got a funnel and the power is going to go out here again. We'll watch it one more time just because it's pretty dramatic. I mean, something happens, boom, everything goes out, and then we start to see those big explosions on the horizon. So again, report what you see. All right, we're winding down. Making a good report. Many of you in this room are associated with formal spotter groups, and you have your own procedures. Some of you in this room are just don't really have anybody to report to. Whoever you're reporting to or however you're making your report, there's some basic information. Identify yourself. Where are you? Give us at the Weather Service especially a location that's easy to find on a map. What did you see and when did you see it? These are my preferred ways to get a report directly to us. If you don't have anybody locally to report to, the preferred method is to get it to a local emergency manager or somebody in your community. But if you're reporting directly to us, the best way to do it is to go to our webpage, click on Submit a Storm Report, fill it out, and within a minute or two, every computer workstation in our office is alarming with your report. It gives us a written record of it. It's time-stamped. And lots of people think they're bugging us if they call us on the phone. This gets around that. So this is very quick and easy. No password, no secret decoder ring code or anything like that. Just get online. Anybody can do this. Spotter Network, I'm going to spend just 5 seconds on this. If you go to spotternetwork.org, that is another system that you can use to get reports to us. And I'll let you go to that website and look at that if you're interested in more details on that. We use amateur radio. We have linked repeater systems that will let us talk to you guys up here and all over the area. So we still use amateur radio, and we still have lots of amateur radio equipment in our office. It is still an important part of what we do. There's people in this room that can tell you how to get involved in amateur radio if you're interested. Email is a bad way to get us urgent reports. So if you send us an email saying there's a large tornado moving into Stillwater, that's not going to get to us very quickly. We may not see that email until the next day. But if you got a report of something, if you said, hey, I went to the lake this weekend and look at this tree I found blew over. Or, hey, take a look at this video I shot. I'm not sure if this is a tornado or just Scud. Or a report that's delayed or something like that. So urgent life and death information, give us that report instantly, but email can be good for other reasons too. There's an app that's available called MPing. This is it's a great way to make very fast reports. You can report hail and snow and sleet and damaging wind and things like that. This is not a great way to get spotter reports to the Weather Service though. Right now we're working on getting it into our system, but right now it's not even in our computer system. We have to go on the web page and look at it, and it's very cumbersome. So you can report hail using this MPing app if you want to, but I still encourage you to report it using the other, a more traditional way too, because it's very hard for us to see those reports right now. So what do you report? The rarest things that you'll deal with are tornadoes, funnel clouds, wall clouds. We talked about those. Most common things are going to be hail, wind, and damage. Report the biggest size hailstone you see. There's going to be different size hailstones out there, but in this case, just kind of eyeball it and say, well, there's some hailstones out there that are between golf ball and baseball size. If you didn't pick up one of the handy-dandy hail scales outside, after the hail has fallen, not while it's falling, go out there and you can kind of gauge how big it is. This is the scale of common objects, kind of common objects that we use. So what we do, if you give us a report of golf ball size hail, we put it in our database as 1.75 inches. I'm still on a crusade to get rid of hen eggs and $50 and teacups off of this scale, so I don't know. We'll find something to replace them eventually, but just give us your best guess. You don't have to measure it. You don't have to have calipers and all that kind of stuff. Just eyeball it and give us your best guess of the biggest size hail that you see. Wind is hard to report because a lot of us don't have wind measuring equipment. If you do and you give us a report, let us know that you measured it. But if you estimated it, let us know that too. I overestimate the wind speeds. It's easy to overestimate them. It's not a big deal. We're not going to, think any less of you if you say it's 50 miles an hour when it's actually 40. Just give us your best estimate. Remember, damage is just as important as the wind. I don't care if you saw the wind blowing or not. If you run across damage, let us know about that. And I talked about this earlier, nothing that you can provide us as a spotter is worth your life. So no report, data, video, image is worth you having to do something dangerous to get it. We roared through this very, very quickly. There's YouTube videos on our YouTube channel where we have some advanced spotter topics. We have more details about all these things that I went through very, very quickly here. Also, we have webinars. We'll have a webinar coming up on March 24th. A 2-hour session, a little bit more drawn-out session on spotter training. And then our advanced session, we'll only do one advanced training session. That'll be on Tuesday, April 7th at 6:30. You can go to our webpage, and it has all the information about how to register for those. If you are really a weather geek and really want to get more into the details, we have people that really just eat up everything they can get as far as severe weather forecasting. This is an extremely rare opportunity. One of the best severe weather forecasters in the country that works for the Storm Prediction Center, Rich Thompson, is offering a free lecture series on tornado forecasting. It started on February 3rd. There's another one going on right now, and you can see the list of topics there. If you go to that URL, this is through the School of Meteorology, you can watch these live as they're going on, or what most people do is they're all on YouTube, so you can go and watch them. They actually are now providing the slides, so when my head would have exploded probably when I was, before I became a meteorologist, if I had an opportunity like this, because this is hearing from the experts in the world about how supercells and tornadoes develop and giving you a 2 or 2.5 hour class that's available. So if you're one of those people that really wants to know more about what goes into forecasting, this is an awesome opportunity. And all the videos are up there. They'll be up there for a long time. So again, go check that out if you're into that. All right, we are late. I'm sorry for that. If you haven't followed us on Facebook and Twitter, do that. I suggest this time of year that it's a good idea if you're into YouTube at all to subscribe to our YouTube channel, because what that will do is it will give you a notification every time we post something new. We'll start posting videos about severe weather, upcoming severe weather. Also, if we're going to continue to post more spotter training videos, you'll get a notification about that, and that's our webpage. So, all right, that's it. I appreciate your attention. Rob, anything else from you? Okay. Thank you for hanging in there. Appreciate it. I'll hang around for questions a little bit, but thank you so much, and be safe out there.